Hi and welcome to a new video. In this video we're gonna continue with the factors that influences or impacts climate. So far so good. We've looked at latitude and we've also looked at elevation and altitude and orographic effects, the windward side and the leeward side. One side has rain, the other side doesn't have rain. The higher you go, the cooler it becomes. So if you have two cities, a city is on a hill and a city is downhill, we expect the city that is on top of the hill to have cooler temperatures because temperatures decreases as one goes higher within the troposphere. In this video we're going to focus on item number 4 here, which is oceanic current or ocean current. Simply put, current is just when things move from one extreme to another extreme. For instance, electric current moving from a negative terminal towards a positive terminal, or when you have water current, which is river flowing from a higher elevation to a lower elevation. So basically it's just a difference in both ends, and then you have something flowing or moving in between those ends. So ocean currents technically are the same as we established when we looked at the factor of latitude. The extreme part of the earth, the higher latitudes around the polar region, they are cold, and then the areas around the equator are pretty warm as well. So there's a difference in temperature. So once there is a difference in temperature, things are going to start to move and flow, creating a convectional current, which means the cold ones move towards the warm side and then the warm side move towards the cold side. So technically speaking, that is what ocean current is all about. Your Earth Science reference table, page number 4, gives a more simplistic view in black and white of what that effect is. For instance, if you look from the southern pole, you see this cool current. When you look at your key here, you have the black arrow representing warm current, and then you have the white arrows representing cool current. So what you would observe is that the cool current are typically emanating from the polar region. All right, so you have that cool current coming from the North Pole, you have this cool current coming from the South Pole. Conversely, you see that the warm currents are all around the equator, moving away from the equator towards the polar region. So the cool currents are trying to come down towards the equator, and then the warm currents are moving away from the equator. So it's like a heat engine. It's a way in which the earth balances its temperature difference. All right, so the guys in the cool side come towards the warm side, the guys in the warm side tend to move back to the cool side, redistributing the heat flow within the planet. So that's what ocean current is simply all about. Notice that this ESRT page number 4 does not only talk about ocean current, it also gives you the lines of latitude. You have your equator right around there, and then you have your Tropic of Cancer, 23.5 degrees north, just above the equator, and all the way closer to the North Pole you have your Arctic Circle, 66.5 degrees north. Below the equator you have your Tropic of Capricorn, 23.5 degrees south, and your Antarctic Circle, 66.5 degrees south as well. Moving down, up and down is the lines of longitude. All right, you have the prime meridian here starting from 0. All right, so that's your prime meridian. Then you have your international date line around the 180 degrees downward. All right, we're going to dive a little bit into lines of latitude and longitude earlier on, but it's important you have the idea that this page gives you lines of latitude and longitude at the same time. So what exactly is the essence of this ESRT page number 4? Simply put, warm current brings in warm temperature and moisture, while cool current brings in cool temperature and lacks moisture. Take for instance the continent North America on the west side, you have the California current, which is a cool current. So it's going to bring cool current and dryness to this west coast of North America. And why on the east coast of America, you see this warm current bringing in warmer temperatures and a lot of moisture. So as a result, you find that there is a great difference in the climate of the east coast compared to the climate of the west coast. Same thing here on the South America, is flooded by warm current on the east side, and then on the west side you're going to have a lot of dryness, technically bringing in cool temperature but a lot of dryness. Hence you see that this part of the continent has a lot of deserts or a lot of dryness associated with it. So that's how basically this ESRT page can be used. The next thing I'm going to talk about briefly is the names. Technically, whenever I hear a name that is Japanese kind of a name, I know I'm looking somewhere around Japan or the Pacific Ring of Fire, or around the these highlands around here. So you have the Oyashi and the Kamchatka, and you have the Kuroshio current all around that region. Whenever I hear any current coming from the Atlantic side, I know it's closer to the South Pole, so I see that Antarctic all around there as well. And then whenever I hear any ocean current that has equatoria attached to it, it means it's around the equator. So you have north equatorial current, you have north equatorial current right there, south equatorial current. So anything that has to do with equatorial, you know, you're gonna find it around the equator. So the ones that you need to familiarize yourself with is the Alaska current, the California current. You should be pretty familiar with those cities in America, and those should be easy for you to locate. The rest, with time and with constant practice, you're going to get used to those names and where you can find them. All right, that said, let's quickly review 2 questions and then we'll wrap it up. Question number 5 says, which surface current cools the climate of the western coastline of South America? So we are looking for an ocean current that brings in cool temperature, because it says cools the climate. So we're looking for a cool temperature on the western coastline of South America. So if you go back to that ESRT, so we have South America here, and we are looking at the west of South America. We did this, and that looks like the Peru current. All right, cool. So our correct answer here definitely will be B. Question number 6 here says the ocean gyre in the northern hemisphere consists of a number of surface ocean currents that together in general flows clockwise in a roughly circular pattern, which list contains 3 warm surface ocean currents that makes up the most of the North Atlantic gyre. All right, the gyre is just another word for current, for something that goes in circle. So we are looking for 3 warm surface ocean currents around the North Atlantic gyre. That should be easy. So we're looking at the North Atlantic Ocean. So Atlantic Ocean is the ocean between North and South America and Africa and Europe. So we know where to focus on. And now we are looking for the warm currents only. All right, we're looking at the warm currents only. So the first warm current here is the North Equatorial current, and then you have the Gulf Stream current, and then you have the North Atlantic current. All the other ones are cool current. So those are the 3 names we should be on the outlook for. The Kuroshio current is definitely in this side, is a Pacific Ocean current, not a North Atlantic Ocean, so that option is out. You have the Canary current, North Equatorial current, and Equatorial counter current. The Canary current is a cool current right around there. Canary current, so it's a cool current. So option B wouldn't work for us either. Lastly, option C, Labrador current and North Atlantic current and East Greenland current. Greenland is all the way up here, so East Greenland current is not part of these that we mentioned earlier on, and besides it's a cool current, so that wouldn't work for us either. So our correct option definitely should be D, the North Equatorial Current, Gulf Stream Current, and North Atlantic Current. Yeah, those are the guys that we are looking for. Those are all warm current. North Atlantic, North Equatorial, and Gulf Stream Current. All right, here's the last point that I want you to take away from this as well. Notice, if you will, that in the northern hemisphere, the places north of the equator, you see that the currents are moving in a clockwise direction, and then in the southern hemisphere, the currents are moving counterclockwise direction. This is called the Coriolis effect, something that would look deeper in person. All right, but take note that the Coriolis effect simply means that in the northern hemisphere, things will go clockwise direction, and then in the southern hemisphere, things will go counterclockwise direction. Gentlemen and ladies, this ends this video for today. I'll see you in the next one. Take care. Bye.